x-axis. And then the other one can be wherever you want, doesn't matter. I'm just going to draw it up here in the first quadrant. This ray that's on the x-axis, this is called the initial ray of the angle. And initial kind of makes sense because that's where it starts. And then the other ray is called the terminal ray. Terminal means like ending, so that's where the angle ends. And when we measure them, they always measure them, well, you actually can measure in two ways, but usually we're measuring them, what would that be, in a counterclockwise direction. So we draw a little arrow here, and then we put our little theta to show that that's the angle that we're measuring. This is what we call standard position, all right? It's never just going to be out there in the middle somewhere. It's always going to be on the x-axis and measuring it, all right? Trigonometry comes from two words, all right? The word trigonometry comes from the word triangle and the word measurement. So what we're going to be spending lots of times on is measuring angles, specifically some triangles, some right triangles. We can also talk about angles going in two different directions. I'm just going along with that. So let's draw another little picture. And now let's draw an angle, but let's draw the terminal ray in the third quadrant. So we're going to draw kind of a very big angle here. So if I want to draw an angle in the third quadrant, my initial ray is still going to be here on the x-axis. But then somewhere over in here, doesn't matter where, I'm going to draw my terminal ray. If you measure your angle in a counterclockwise direction, so if I go from here to here, I'm going to call that angle alpha. That's like a fish. So if you go in a counterclockwise direction, this will always be measured with positive numbers. All right? So if you measure in a counterclockwise direction, then it's a positive angle. What you really haven't probably done before, especially in geometry class, pretty much everything we deal with is positive. We can actually measure angles in a negative, with negative numbers, and all you do is you change the direction. So if I went clockwise, so what if I measured from this initial ray and I went clockwise like this? That's also an angle, right? From here to here is an angle. I call that beta, which is kind of like a V with a tail at the bottom. Again, I don't know why we always use Greek letters for angles, but we do. If you measure clockwise, you will always get a negative angle. All right, and so sometimes you can give me different answers, one positive, one negative, and it's actually the same angle. And there's a special word for that. These are called coterminal angles. So my two angles that I drew up here, alpha and beta, are called coterminal. And one definition of a coterminal angle is that they have the same initial and terminal rays. You just measured them in a different direction. And again, the more we do this, the more we deal with it, the easier it'll get, and soon it'll be just second nature to measure those angles negative. But coterminal means they have the same rays of their angles. The really easiest one to do that would be, well, let's just wait, because I don't want to talk about degrees yet. Can I go? Not go? Maybe go. The next thing I'm going to give you is a little radian degree measure by quadrant, just to kind of give you a reference thing to look back at. Hopefully the degree part's going to make sense to you, and then I'm going to give you the radians that go with it, so that we can start thinking about how many radians, how much is 3 pi fourths? Where would that be? So let's think about degrees first, because I feel like that's what people are the most comfortable with. If I start here and I make this 0 degrees, what would be the angle if I was up here on the y-axis? From here to here, how far is that? 90 degrees, right? So right angle. So if you wanted to say in quadrant 1, in degrees, every angle in quadrant 1 would be bigger than 0 degrees, but less than 90 degrees. I don't know that we really need to write that down, but I'm going to for you. What about here? What if I measure from 0 all the way over to here? How many degrees is that? It's a straight line. It's 180 degrees, right? We call that a straight angle. 180 degrees. So in quadrant 2, all of your angles are between 90 and 180. So if you wanted to write that, you could say everything is bigger than 90 degrees, but less than 180 degrees. What if I went all the way down here? What if I went all the way around to this point? How much would that be? How can I figure out how much that would be? This much is 180, yes? Plus another 90, right? 180 plus 90, Logan says 270. So every angle in quadrant 3 is greater than 180 degrees, but less than 270 degrees. And if we go all the way around the circle, how many degrees are in a whole revolution if we made this big, nice angle? 360, right? I'm not going to write 360 here because I already have 0 here. But we could say every angle in quadrant 4 is bigger than 270 degrees, but less than 360 degrees. Hopefully you're kind of familiar with that. Radians is what we're going to be working on. And you don't want to be converting every time. When I first learned radians in high school, I was very anti-radians, and I would convert every time. If they gave me 3 pi fourths, I'd convert degrees, and then I could do it. But it's really not that bad, especially if you think about, what do we know about the entire circle? If we go all the way around, how many radians would be in a whole circle here? 2 pi. So let's think about that. If the whole circle is 2 pi, how much is half of it going to be? 1 pi. So we could say that this is the same as saying pi. So from here to here is pi. So now think about it in terms of that. If from here to here is pi, what would up here at 90 degrees be? Half of pi. Does that make sense? Just like half of 180 is 90. If this is pi, if I cut it right in half, in the middle here is going to be pi halves. And you can do the conversion, it always works, but it's kind of nice to know some of those basic ones. So I can go ahead and say quadrant 1, everything in quadrant 1 in terms of radians is going to be less than pi halves, but bigger than 0. And notice I'm not putting the degree mark on that. 0 radians, you just write as 0. And I could say the same thing for quadrant 2. I know this is pi halves, so everything is going to be bigger than pi halves, or half of pi, but less than pi. I go this extra little bit here, what's this one going to be down here? How much am I adding to pi to get down to here? Another half. Do you agree with that? Just like to get from 180 to 270, you take 180 plus 90 degrees. If I take pi plus a half of pi, how much do I get? Pi and a half, but that sounds kind of funny to say pi and a half. Could I say 3 halves pi or 3 pi halves? You're right, pi and a half is exactly the right thing, but I'm just writing it as an improper fraction. So we don't usually write mixed numbers with but that's how you get that. This is 1 and a half pi. So it should make sense. If you know this is pi, if you go another half, you're going to end up down here at the middle between the third and fourth quadrant. So I can say that everything is smaller than 3 pi halves, but bigger than pi. And in quadrant 4, everything's going to be bigger than 3 pi halves, but smaller than 2 pi. Now notice I did this for all positive angles. If we were measuring negative, everything's backwards. So this is just for if we're measuring the way that we measure positive angles. But that's kind of a nice little reference for you. I think you have some homework problems today that ask you what quadrant is this angle in. One option, you can convert it to degrees. I'd like you to try to think about it in terms of, do I know where that is, and then maybe convert it to degrees, because you're not going to want to convert every time. Okay? All right. I haven't even done an example yet. What do you think about that? All right, so I got some more about coterminal angles, and then we'll do a few examples, and I'm almost done. The definition of coterminal angles is they share the same rays. One way that you can have coterminal angles is to look at one going positive and one going negative. But I also want you to think about coterminal angles in another way. And so we're going to make a nice little angle in quadrant 1. I'm going to make a pretty small angle. And I'm going to make pi sixths, which is, I think, about 30 degrees. It is 30 degrees. But think about pi sixths would be if you broke theta equals pi sixths. You want to write that in? I feel like when you learn trig and you learn radians, you become better at fractions probably than you ever been, because you have to think about what does that mean. That means 1/6 of pi. So how do I know that that's there? Think about this is pi over here. So if I broke this up into 6 equal parts, do you agree each of them would be a pi 6? And so that's kind of how you can visualize this would be pi 6, 2 pi 6, 3 pi 6, and on from there.
How do you know?
So I kind of just made this angle up. So
How do you know, like, you're measuring positive?
if you're measuring from this in a counterclockwise direction, it'll always be positive.
It'll always show an arrow which way you're measuring.
Yes, yes.
So if you're measuring it, if the arrow is down,
If the arrow was down, we would measure it from here all the way around. What would that angle be? If we were measuring from, or how could I figure out what that angle would be? It's almost the whole circle, right? Except for how much is not included. Yeah, 1/6 of 2 pi. So it's kind of like you could say this would be 2 pi minus pi 6. So that would be, if I got a common denominator there, that would be 12 pi 6 minus 1 pi 6 would be 11 pi 6ths. You with me on that? But is it going to be positive or is it going to be negative? Negative. So if the arrow went like this, we would say that this angle would be negative 11 pi 6. Does that make sense on how you would know? Kind of. It's all about knowing that it's all 2 pi. But I want to show you another way that we can do coterminal angles. What if instead of going the negative way, what if I went and I started here, but I went all the way around the circle, and then I went back again to that same terminal ray? So you follow me on that? I started at the initial ray, I went completely around the circle, and I went back up to that same terminal ray. Do you agree that that meets the definition of a coterminal angle, that's still the same initial and terminal rays? I don't know what to call this one. Let's call this blue one alpha here, just because I can squish it in there. What would the measure of that angle be? It would be 2 pi plus that same little amount that I went, which was pi 6. Which means you can have angles bigger than one time around the circle. It's kind of weird to think about, but we can just keep going around and around if we want. And again, on your calculator, you can do this, and you can just add it and then put pi at the end. Like you can take 2 plus 1/6, or you can just think how I did up here. This would be 12 pi 6 plus 1 pi 6, which would be 13 pi 6. We've actually just found 3 coterminal angles. Pi 6 is the same as negative 11 pi 6, which is the same as 13 pi 6. And you could actually keep going. I don't want to keep drawing because it gets really messy. What if I went around the circle 2 times and then up a little bit again? It's the definition of a coterminal angle is they have the same range. So you end up in the same spot. Do you agree with that? You end up in the same spot even though you went around a bunch of times. So I don't know if I wrote this down here or not. Oh, yeah. Every angle that you can come up with will have infinitely many coterminal angles because you can always keep going around the circle. You can just keep adding 2 pi over and over again. You could also go the other way. You could also keep subtracting 2 pi. And so I think I wrote a little formula here. If you wanted to write all coterminal angles, all you got to do is take the angle, and I just wrote angle sign here, but if you want to write, maybe write theta there, I don't know. Theta plus 2 pi n. Notice my angles in radians here because I can't add 2 pi to degrees. Oh, and what does that mean? It's a nice little math notation for you. This means that an n is an integer. So n is an integer, which means it's not a fraction, it's not a decimal. So the great thing about this, or maybe the not so great thing about this, is if it asks you to give a coterminal angle, there are infinitely many answers. And most of the time, people just add 2 pi or subtract 2 pi. But you could really add or subtract any multiple of 2 pi. So if you really wanted to make me do my work when I'm grading your test, you could add 100 pi, and then I have to get my calculator out and make sure that it's the right answer. But you just can keep going around over and over again if you wanted to. If you added 4 pi to this, you don't have to draw this, but it would be like you go around once, you go around twice, and then you go again, and you end up in the same spot. It's kind of crazy. So let's practice a couple before we run out of time. This one just says the directions just say find a coterminal angle. Sometimes it might say find 2 coterminal angles. Sometimes it might say find 1 positive and 1 negative coterminal angle. But just know to find a coterminal angle, all you have to do is add some multiple of 2 pi. So I'm just going to put plus 2 pi in here. Kind of refers back to our last one. Maybe we'll only do like 2 of these. It doesn't matter which way you do this, whether you add 2 pi or subtract 2 pi. I want you to think about in terms of maybe getting to an angle that would be smaller. So when you see 11 pi fifths, can you tell me if that's bigger than 2 pi or smaller than 2 pi? Because what would 2 pi be in terms of fifths? 10 pi fifths. You kind of see how we see that? 11 over 5 is bigger than 2. So this has already been around the circle more than once. If you want to keep going again, you could add 2 pi here. It's going to work. But for me, that's a big number already. So what if we just subtract 2 pi from this? Would that get me back another angle? And it'd be a much smaller angle. It's okay, whichever way you do it. You could add 4 pi here. You could add 10 pi here. I don't care. Again, you can use your calculator, but I'm just going to show you it's not so bad to do here. This was 11/5 minus 2. Just leave the pi out of it and then put pi back in your answer. Because the pi's in both of them. But 2 pi is 10 pi fifths. So if I took 11 pi fifths minus 10 pi fifths, one of many, many answers that you could give me here would be pi fifths. You're with me on that? I don't care whether you add or subtract there. I was just kind of showing you what I think about. Like for this one, pi thirds. Is pi thirds bigger than 2 pi or smaller than 2 pi? It's smaller than 2 pi, which means if I choose to subtract on this one, I'm going to get a negative angle. That's okay. But for me, that's kind of how I decide what to do. So for me, I'm going to add 2 pi on this one to get my answer. And again, you could just take 1/3 plus 2. But that would just be 6 pi thirds. So 7 pi thirds would be my answer. Negative pi ninths. Again, you have options here. It's okay to make it more negative if you want. Sometimes I like to get a positive angle, and you're going to see that as we start graphing them. Sometimes a positive angle is nice. So when I see a negative angle, I'm usually going to add 2 pi. And just watch your signs here. Again, calculator works fine. But if I got a common denominator here, that would be 18 pi ninths. Negative 1 pi plus 18 pi would be 17 pi ninths. So coterminal angles, not such a terrible thing, hopefully. You could give me 7 coterminal angles if you wanted, because you could just keep adding or subtracting 2 pi. All right. You could add 2 pi again, or you could go back here and subtract 2 pi. But yes, you could just keep adding 2 pi, and you'll just keep getting in the same spot, because 2 pi gets you all the way around. Okay? All right. I got one more thing here before we run out of time. Soon, right? 55, is that right? 5-time day. Sketch each angle in standard position. You have a couple options here. Like I said, you can convert these to degrees because it's easier to think about degrees sometimes, but I really want you to try to think about these in terms of radians and what you know about the radians. That little chart I gave you might be helpful. Standard position means you need to have an initial ray and a terminal ray, and you need to show the direction of the arrow. So if I'm going to graph 5 pi force, that's a positive angle, so I'm going to make sure I'm going to go clockwise. And I'm always going to start here on my x-axis, no matter which way I'm going. And I just want you to start thinking about, I always think about it in terms of pi, but go from there. If this is pi, is 5 pi force going to be bigger than pi or smaller than pi? Bigger, right? How much bigger? Like a fourth bigger. Do you agree with that? Do we know where a half of pi is? Where would a half more than pi be? All the way down here? You follow me on that? So where would a fourth more than that be? Directly in the center. Kind of follow me on that? If this is pi, you could break this up as pi plus pi force if you really wanted to think about it. That's how 5 pi force is. I need to go a fourth more, and so I'm going to just kind of go directly in the center and draw a line. And that would be the angle of 5 pi force. But you have to label it, which means you have to show me the direction that you're going, because otherwise I don't know if it's positive or negative. And then you probably want to put, I don't know, either 5 pi force there. I usually put like theta equals 5 pi force. It's not wrong today. Change that to degrees, and you're going to get 100 and, no, what is that? 225, I think. Which would be, I think that's 235. But that's the idea. What? 225, is it 225? Are we gonna run out of time? I think I'm gonna maybe stop. Yeah. If it was negative, all you gotta do is the exact same thing, but think about we're going in this direction, and you would label your arrow going this way. We'll talk about this more tomorrow. I know that's the hardest, maybe the trickiest part. Don't leave, I have a type it for you. Your homework is not in your book today. Your homework on your assignment sheet, this is 4-1, day 3. But this is from another textbook, so
So do we need to copy that?
Please, I think it's like Clark.
it's on your assignment sheet.